Hello students, the purpose of this video is to discuss various measures of averages. So one popular term that we use are the measures of central tendency. Basically, this is a summary measure that attempts to describe a whole set of data with a single value that represents the middle or center of its distribution. So there are actually three main measures of central tendency: the median, the mean, and the mode. So whenever you are asked what are the measures of central tendency, you would respond by saying the median, the mean, and the mode. Each of these measures describes a different indication of the typical or central value in the distribution. And each has its pros and your cons depending on your actual data set. It may be better to use the mean or the median or the mode at various times. The mean is something that you're all probably familiar with. You basically are finding the average. And to find the average, you add up the numbers and you divide by how many numbers there are. So when you look at your grade in a class, you add up all of your grades and you divide it by the number of items that there are, and that determines your particular average in a respective area of the class. But sometimes the mean can let you down. It can be accurate, but not always useful for the data that you have. So I've given you an example here of some birthday activities where there were 6 kids that were all 13 years old, and then there were 5 babies that were all 1 year old. So you have 6 13-year-olds and you have 5 1-year-olds. And if I want to find the average age, I would add up all 6 of those 13 values and all 5 of those 1 values, and I would divide that by 11 because there's a total of 11 kids, and I get 7.5, which is saying that the mean age of the individuals at the party is 7.5. But that's not very accurate, right? Everybody was literally either 13 or 1. So to say 7.5, there was nobody there that was near the age 7.5. So the mean honestly isn't a good predictor of the data, nor is it a good central value of what was going on at this particular party. Now, there are some advantages. It can be used for both continuous and discrete numerical data, but it cannot be calculated for categorical data because the values cannot be sums. So, for example, if I want to look at, the eye color of everybody in this class, I can't find the mean eye color. Eye color is not going to be a solution to finding the mean of some values. Can't happen. And as the mean includes every value in the distribution, it's often influenced by outliers and skewed distributions. The median is the middle value. So you want to start by listing out whatever your data is in chronological order, starting from smallest to greatest, and then you're literally going to choose the middle number. So this is a very unconventional way of doing this, but this is how I learned it. You start on one end, cross out the number, go to the other end, and cross out that number, and then cross out, 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 and when you have nothing else to cross out and you've done it evenly, that middle value represents your median. But sometimes you'll do the cross out process and you'll end up with 2 numbers. So cross out, cross out, cross out, cross out. And if I were to cross out and cross out, I wouldn't have anything left. So when I have 2 values, I actually go and average them and then divide by 2. So I would add those 2 values up, divide by 2, and then that gets me my median value of 8 in this particular case. So the way that I like to remember median is it stands for the middle. Think about where the median is at in a road. So where's the median located? In the middle of the road. So quirky little way to remember it. Some advantages is that it is less affected by outliers and skewed data than the mean, and it's usually the preferred measure of central tendency when your distribution is not symmetrical, but it cannot be identified for categorical nominal data as it cannot be logically ordered. Another term that we have is the mode, another measure of central tendency. So the mode is the number that occurs most often. So think of mode, most. Both of them start with the word mo. Mode, most. So you're literally looking to see which value has the highest frequency, which value occurs the most often. So for this data set, I would say 13 because that occurred 6 times, whereas the value 1 had a frequency of 5. Mode can be tricky because sometimes there is more than one mode, so it is possible to have several mode answers, so that actually serves as a disadvantage for us. An advantage over the median and the mean is that it can be found for both numerical and categorical data, but again, there are some limitations. It may not always reflect the center of the distribution. If you do have more than one mode, so it'd be bimodal or multimodal, that can limit the ability of the mode in describing the center or typical value of the distribution, because if I want to identify the center, I only need one number, but if I get 5 different modes, then how do I pick which one's the center? I can't. In some cases, particularly where the data is continuous, the distribution may have no mode at all, so it is possible to not get an answer. It may be that every data point has a frequency of 1, and so there's no way to determine a mode. And so it may be better to use the median or the mean in those type of situations. Now, outliers lie outside the other values, so they are values that are not consistent with the majority of your data. So maybe you have a lot of points like 1, 2, 3, 4, 5, and then all of a sudden you have this point of 100, right? That's like way out there. It's not consistent with the majority of your data. That would be considered an outlier, and it tends to throw off your measure's essential tendency significantly. And so here I have a picture showing you the different measures of central tendency and how each of those tendencies can be affected by an outlier. The mean tends to be the measure that is most affected by outliers, which is why when you average up your grades in a course and you have like all hundreds and 95s, and then you get this outlier grade of a 5% because you failed or maybe you didn't do the assignment, your grade plummets because that outlier will affect your overall average. So now thinking graphically about this, there are symmetric distributions. This is a perfectly symmetric distribution because the median, the mean, and the mode all equal the same value. You'll see that if I were to draw a line or like a curve to represent this data, that it makes this like bell shape. So when you actually get into statistics, you learn that this is a bell curve distribution, which is a perfect symmetric distribution. But it is possible for me to be skewed right. Here, my mode and median are going to be smaller than my mean. And identify how the data is skewed by the tail. So because the tail is on the right-hand side, that's how I identified that it's skewed right. And when I look at skewed left, the mode and the median are larger than the mean. So when I make my curve, again, the tail this time is on the left-hand side. So that's how I would identify it as being skewed to the left. As always, I hope you found this video helpful and that you have a better idea of measures of central tendency. If you have any questions or concerns, please don't hesitate to reach out, and have a wonderful day.